For today's enrichment lesson, we are going to be looking at tape diagrams. So this is another way to visually display ratios. So a tape diagram is a visual model that uses, rectangles to represent the parts of a ratio. So this is an example. It's showing the shoes has 5 rectangles and the sneakers have 2. So the ratio of shoes, which has 5 rectangles, to sneakers, which has 2, is 5 to 2. It's matching the rectangles. So let's look at how these would be used in a problem. Solve the following problems using tape diagrams. Kenzie makes some quilts with some blue squares and some green squares. The ratio of blue squares to green squares is shown in the tape diagram below. Based on the ratio, how many green squares do you need if you have 21 blue squares? So we are going to be setting up a proportion using the ratio given in the tape diagram. So we are comparing blue to green. Okay, our ratio is that there are 3 blue square rectangles for 1, 2, 3, 4, 5 green. So our initial ratio is 3 to 5. Then I'm going to go back in my problem and I'm going to circle the number and the corresponding unit that's given to us. So 21 blue. So what that means is that 21 needs to match up with the blue that's on top. And we are solving for, if you look and underline, how many green. That's what we are solving for. Now, we're looking at our 2 diagonals. We have diagonal 1, diagonal 2. The one that has 2 numbers in it is this yellow one. So that's what we're going to multiply. We're going to do 5 times 21. And you can plug that into your calculator. So 5 times 21 is 105. And then we divide by the number that's on the same side, same diagonal as the variable. So we divide by 3, which tells us 105 divided by 3 is 35. And what were we solving for? We were solving for G, which was green. So 35 green squares. All right, next one. Jeremiah created a new energy drink by mixing pineapple juice with apple juice. The ratio of cups of pineapple juice to cups of apple juice is shown in the diagram below, in the tape diagram below. Based on the ratio, how many cups of apple juice would be needed with 22 cups of pineapple juice? So again, we are going to be setting up a ratio, or a proportion, sorry. And we are comparing pineapple juice to apple juice. So we're going to look at the ratio here. There are 2 rectangles for pineapple juice to 1, 2, 3, 4, 5, 6, 7 rectangles for apple juice. So our ratio is 2 for pineapple, 7 for apple. Then we're going to go back into generally the last sentence here to look at the number that's given to us, 22 cups of, and I'm going to circle the whole thing so I know what it's talking about. It's talking about 22 cups of pineapple juice. So we put the pineapple juice on top, so 22 is going to go here, which means we are solving for the apple juice. And if you look, it says how many cups of apple juice. That's what we don't know. I'm going to highlight my 2 diagonals in my proportion. The 2 numbers that I multiply together are the ones that are in the same diagonal. So the 2 numbers that are in a diagonal together are 7 and 22. So I'm going to do 7 times 22, which equals 154. And then we divide by the number that's in the same diagonal as the variable, which is 2. So divided by 2 gives you 77. What were we solving for? We were solving for the A, which was cups of apple juice. Sorry, that was cut off a little bit. Next example, number 3. A recipe for pizza dough requires 3 teaspoons of salt for every 4 cups of flour. The ratio of teaspoons of salt to cups of flour is shown in the tape diagram below. Based on the ratio, how many teaspoons of salt will be needed with 28 cups of flour? So again, we're going to be setting up a proportion. We are comparing the salt to flour. We're going to look at our tape diagram. There are 3 rectangles for the salt for 4 rectangles with flour. So our initial ratio is 3 to 4. 3 teaspoons of salt to 4 cups of flour. Go back into our problem to generally where the question is at the end. With 28 as our number, but what is that 28 talking about? 28 cups of flour, which means our number needs to match up with flour, which is on the bottom, which means our variable, our unknown, should be with the salt, which makes sense. If we look, it says how many teaspoons of salt. I'm going to get out my 2 highlighters. I'm going to highlight both diagonals in my proportion, and we're going to solve. So the diagonal that has 2 numbers in it this time is this pink diagonal, the 3 and the 28. So I'm going to do 3 times 28, which is 84. And we divide by the number that's in the same diagonal as the variable, and that is 4. So 84 divided by 4 is 21. What were we solving for? Our x lines up with salt. So teaspoons of salt. Number 4, a wedding planner requires a certain amount of chairs per table. The ratio of chairs to tables is shown on the tape diagram below. Based on the ratio, how many tables will be needed with 175 chairs? So again, setting up a proportion. We are comparing tables to chairs. Let's look at our, I'm going to do it in a different order. I'm going to match this. We did chairs first here, tables here. Technically, you could do it either way, but this is the order we've been kind of going with this whole lesson. So there are 1, 2, 3, 4, 5, 6, 7, 8 rectangles with chairs and 1 rectangle with tables. So our ratio of chairs is 8 to 1 table. Then I'm going to look at the question. Based on the ratio, how many tables will we need with 175 chairs? So the 175 is talking about chairs. We put chairs on top, so that's 175, which means that we are solving for the tables, and if we double check, it says in the question how many tables. I'm going to highlight my 2 diagonals. Diagonal 1, diagonal 2. And then we're going to solve this proportion. The diagonal that has 2 numbers in it is the yellow diagonal here. So I'm going to multiply 1 times 175, which equals 175, and divide by the number that's in the same diagonal as the variable, which is 8. So 175 divided by 8 equals 21.875. I'm okay if you leave it as a decimal. Does it really make sense, though, to say that we need 21.8 tables? Probably not. They're not going to chop part of the table off. They would just round up and say, okay, we need about 22 tables. And you can always check what you're solving for. Our x was on the same level as t for tables. All right, one more problem. A vegetable garden has some tomato plants and some lettuce plants. The ratio of tomato plants to lettuce plants is shown in the tape diagram below. Based on the ratio, how many tomato plants would there be if there are 45 lettuce plants? So we are going to be writing a proportion. I'm going to set that up. We are comparing tomato plants to lettuce plants. There are 3 rectangles with the tomato plants. There's 1, 2, 3, 4, 5 rectangles with lettuce plants, sorry. So our ratio is 3 tomato to 5 lettuce. We look at the problem. It's asked, the number that's given to us is 45 for lettuce. Lettuce is on the bottom, so I'm going to put 45 here, which means we are solving for tomato. And if we look at the question, we underline, it's asking how many tomato plants. I'm going to highlight my 2 diagonals. And solve this proportion. The diagonal that has 2 numbers in it is our pink diagonal here, 3 and 45. So I'm going to multiply 3 times 45, which is 135. And I'm dividing by the number that's in the same diagonal as the variable, which is 5. 135 divided by 5 is 27. What were we solving for? Our x matches up with tomato, so 27 tomato plants. And that's it for tape diagrams.